On page 406, you're having a quadratic, and on this quadratic, its vertex is on 0, 4. We want to be able to find its inverse, because our goal is to graph and find the inverse of square root functions in quadratics. So going from a quadratic, we're going to create a table. So we have x and f of x. Looking at our values, I'm going to go from negative to positive, so negative 2, negative 1, 0, 1, and 2 are my x values. Now on page 406, you can find your y values, but to be exact, they are going to be from negative 2, we have 8, same with positive 2, negative 1 and positive 1 both have 5, and on 0 we have positive 4. So those are what those points are. Now in order to find our inverse, we're going to switch the x and y values. So for our inverse, I'm going to put it on the bottom of this paper, and we're going to have a table. And on the table, I have x and f of x. So I'm going to switch my x and y values. So I'm going to go write 8, 5, 4, 5, 8. That's going to be on the left. And now my values for y is negative 2, negative 1, 0, 1, and 2. Okay, so now we're going to plot the points. So when x is 8, we get negative 2. Negative 1 when x is 5, 4 is 0, and vice versa. So now we have this quadratic facing the other direction. Now, on the inverse, this is not a function. On the original, it does. Now we're also going to compare the domain and range. Okay, so with our domain from our original function, which is the one facing up, we're going to clarify it. So the domain for this original one is all real numbers. So I'm just going to write that as a integral. So negative infinity, open parentheses for both sides, to positive infinity is my domain. My range for my original is y must be greater than or equal to positive 4, so I'm going to write 4 to infinity. So this is for my original function. Now we're going to base it off of our inverse. So for our inverse now, our domain is starting here, which is positive 4. So my domain for my inverse is from positive 4 to infinity. My range for my inverse is now all real numbers. So it gets reversed. Alright, so now we're going to do it by algebraically. So we're going to have f of x is equal to the square root of x plus 3. In order to find the inverse, we switch x and y. So first I'm going to write y equals the square root of x plus 3. Next, I'm going to switch x and y, so now I have x equals the square root of y plus 3. In order to get rid of a square root, we're going to square it. So now I have x squared equals y plus 3. Last but not least, I'm going to do x squared minus 3 equals y. So my original is f of x equals square root of x plus 3. My inverse is now f prime of x equals x squared minus 3. Now, we're going to do our domain and range for both of them. So my domain for my original is x such that x is an element of all real numbers, where x is greater than or equal to negative 3. The reason why it's greater than negative 3 is because inside the square root, if we do anything less than negative 3, we're going to get a negative number, and we can't do a square root of a negative number in order for it to be a real. Okay. Now we're going to find our range. So our range is going to be, well, and there's no numbers that if I put negative 3, negative 2, I'm going to get all range of numbers. So my range is going to be all real numbers as well. All right, so now we're going to go into a quadratic. So this one is a square root. This is where we started off at. And then we're going to go to a quadratic. So my inverse of a square root is a quadratic. The inverse of a quadratic is a square root. So my domain here for any quadratic is going to be all real numbers. And my range Well, it's just the inverse of my original, so it's going to be y such that y is an element of R, where y is greater than or equal to -3. Okay, here is another example. So this one I'm going to go from a quadratic to a square root. All right, so we're going to have an example 2. F of x equals x squared plus 14x plus 49. All right, so my first step is to rewrite it as a perfect trinomial. So if I refactored it, 2 factors of 49 give me 7. When I add them, I also get 14. So my new one is f of x equals x plus 7 squared. Now I'm going to find the inverse. So we have y equals x plus 7 squared. I'm going to switch x and y. So we have x now equals y plus 7 squared. The inverse of squaring is the square root. So I'm going to find the square root of both sides. When I find the square root of a number, I always get 2 answers. So I'm going to write plus or minus the square root of x is equal to y. And then plus 7. In order to get y by itself, y equals 7 plus or minus square root of x. Alright, so now we're going to discuss the domain and range restrictions on your inverse. So my inverse is f prime of x is equal to -7 plus or minus the square root of x. So remember in the beginning, we went from y equals x squared plus 14x plus 49. It broke into x plus 7 squared. When we found the square root, now we have to think about what number we cannot plug in for x. Well, the only number we cannot find the square root of is a negative number. So here restricts our inverse that x must be greater than or equal to -7. Okay, so another situation would be like that would be, let's say, for example, if I have y equals x squared plus 16x plus 64. This can be broken into x plus 8 squared. When I find the inverse here, and I switch x and y, this is restricting what I have to be on the square root. So my inverse is going to have a restriction where x must be greater than or equal to -8. So for your inverse on this function, your domain is x such that x is an element of real numbers where x is greater than or equal to -7.